Okay, everybody, good morning after Thanksgiving. Good morning to you. We do have some people online, so all right, let's double check and take a look and see what we're going to be working on today. And of course, I'm going to go here to my website, and you guys can see this here. We're going to go to Math 241, and we're going to be looking at the video library here. Scroll all the way down, and we're going to start working on what's known as vectors. Yeah, vectors. Okay, so we're going to give it some time to wake up, and then we're going to import this into Notability. Okay, here we go. Vectors, ladies and gentlemen. Vectors. Now, I have these notes, so what you guys can also do, if I go back here, I'm going to put the notes here in our, whatever this is, comment section. So we have this worksheet in video library. It'll be here for you, vectors. It's waking up. There it is. So I put the notes in the comments section for you guys. Now vectors. Now, if you see this and you think of a vector, right? What do you guys think a vector actually is? Let me take a look at this here. What do you guys see here? You might say, this looks to me like a what? Like an arrow. Is that true? All right. You say, that looks to me like an arrow. And I say, yeah, you see, this arrow here is the physical object that's representative of a vector. And you say, well, I see various arrows here. You do. You see an arrow, here as well. You see an arrow over here. You see an arrow here. You see an arrow here. So we see arrows, ladies and gentlemen. Where everywhere you see arrows, that's called a vector. So you see a lot of different vectors. Now, a vector really, how we describe it, as an object that has both magnitude and what? Direction. So if anybody ever says to you, like tonight over dinner, hey, what is a vector? You can say it's a what? It's an object that has both magnitude and direction. It has two quantities associated with it. The magnitude is really length. So every one of these vectors that you see here has a particular length. Is that right? Some are longer than others. Some are shorter than others. So it's an object that has length, and then it's pointing in a particular direction, what we call theta. So a vector is an object that has both magnitude and what? Direction, ladies and gentlemen. And what they're used in science. They're used to represent forces. They're used to represent any sort of, I should say, piece of information where you care about a magnitude and a direction. And that's why we study them. We study them in science because they're very useful. What's that? There's no such thing as a vector without direction. Every vector, scalar just means number. So a scalar means number. So ladies and gentlemen, you have here a vector. Has length and it has what? Direction. All right. So now you say, what's the geometric description of a vector? Well, in order for you to start to get some information here about what a vector is, you need 2 points here. Okay? So we have what's called the point A and a point B. This is in two space. In other words, these are addresses. A point is an address, right? And A is the initial point. B is the what? Terminal point. Okay? So you have an initial point. You say, what's an initial point mean? It's a starting point. That's the name of it. Then you have the ending point, B. Now, the reason you need to have that information is because when you draw your arrow, okay, when you draw that arrow, you got to know where's the initial point and the terminal point. You got to know where to start to draw the arrow and where to end, because it has to have a particular what? Direction. It's pointing in a direction. Okay, and you say, well, how is that pointing? Well, remember this here, this horizontal. If you draw a horizontal here, it's pointing with this angle theta here. That's what they mean by having a particular direction. It's pointing some angle theta here. So you do have to have the initial point and the terminal point if you're going to draw the correct arrow with the appropriate angle that you're trying to communicate with people. So we want to know what that looks like. And then this notation, you say, what is this notation over here? Well, this absolute value notation here represents what we call the magnitude, the length of the vector. So this here is really the notation, again, for the length of your vector. That's how we describe the length, the vector length. So you're looking at a couple of things here. The length of this vector, whatever that is, and you have the direction, the magnitude and direction. So 2 points in space can define a vector. Now take a look at how they do this. A gets listed first, B gets listed second, and then a lot of times they'll just draw that little arrow on top, okay, in terms of notation, and then just name this vector V. Okay? So we're kind of diving into the details of what a vector is. You need 2 points in a plane to define a vector. You go, okay, let's see. What do you mean? Well, here's 2 points on a plane, right? And this is called the Cartesian coordinate system. Every point has an address, x and y. So A will have an x coordinate and a y coordinate. B will have an x coordinate and a y coordinate. Okay? And so we're drawing them on our Cartesian coordinate system. Like in this example, they say, oh, okay, let A have the point 1, 2, and B have the point 6, 5. They want you to determine this vector V now. Where remember, you have, again, an initial point, starting point with these coordinates, and then you have the ending point, B, with these coordinates. So in this example, they want to give you the starting point, the ending point. And what they want you to do is to describe or create vector V. And you might say, well, how in the world do we do that, right? Well, here's how they do that. This is just a sketch for the beginning here, okay? So notice, if you guys remember how to plot points, this is 1, and this is up 2. So you go to the right 1, up 2. This is the location of A, your initial point here. And then B is all the way over here at 6. So the terminal point, the point where you end, goes over here at what? This is 6, and this is 5. So this is just a sketch, and draw the arrow pointing to B, okay? Because, again, it's read AB as you read left to right. A being the initial point, B being the terminal point. And so you get to describe this vector here. Now notice this vector has a length, it has a magnitude, is what we're saying, and it even has a direction, theta. There it is. Terminal point. All right, so we're going to dive into the details here, okay? Now here is some of the details here, because we're going to now have to determine, you know, how we're going to actually, you know, find the length of that vector and the angle theta, the direction, right? So you have these points here. Now let's see. We can determine the magnitude length of our vector and its direction theta by considering two quantities, the horizontal component of a vector and the vertical component of a vector. So here's kind of what you're looking at algebraically speaking here, ladies and gentlemen. You got 2 points again. You got your initial point right here. You got the terminal point right here. And you draw your arrow here. There's your arrow. And you got this angle theta right here, okay? So that's the picture we've been looking at. And if you notice, this forms a right triangle. Is that right? So if you wanted to know the distance, what we call a horizontal distance again. So let me erase these colors here and focus right down here. The horizontal distance here, you might say, how do we measure that? Well, remember, this here is an x-coordinate value named x1. This over here is an x-coordinate value named x2. This here is your what? Horizontal distance. Yes?
So I presume that we do x1 minus x.
Well, that's what we're going to get at here, okay? This is what we're going to get at now. I want to remind people, because there's a lot of people that maybe don't know how to measure. You say, what do you mean? How do you measure the distance between two points on a horizontal line, right? So at times, you know, you go, wait a minute, Mr. Judge, how do I, here's a point on a horizontal line. Let me get the blue so we can see it. Here's another point. Do you guys know how to measure that length? That length is always going to be right minus what? Left. That distance in gray is the right value minus the left value. And that's why you see this information where that length is the horizontal component. This is the distance here. So you have to get the right value minus the left value. Here's the right value minus the left value right here. And that's the distance that we call A here, ladies and gentlemen. And that's important. That's the horizontal component of your vector down here. This vector, this blue vector. Okay, now horizontal meaning left and right. You also have a vertical component. You go, vertical? Yes. So these points over here, if I kind of remind people here, on the y-axis, this coordinate here will be y1, y2. We're going to try to find again now, using the same idea, this distance here, which is really the same as this distance. Okay, we're going to now find what's called the vertical component. Now, notice you say, I can see already it's y2 minus y1. Why? Well, similarly, if I get rid of the purple, how you can find vertical distance always will be top minus what? Bottom. So if you get the top value, y2, the bottom value, y1, We call that the vertical distance, represented by the letter B here. Top minus bottom. There it is. There it is. So you're going to have the horizontal component and the vertical component. That's how you measure these values for your vector. All right, you get the horizontal and the vertical components. Now, you guys know by now, this is A, this is B. If I want to find the magnitude of my vector, this length, right, is C. What do we use? The Pythagorean what? Theorem. So that C squared will be A squared plus B squared. So we can use Pythagorean theorem to find the length of the vector. C squared equals what? A squared plus B squared. All right, you guys okay with that? Pythagorean theorem. How do we find this angle theta? You guys should know. What's the relationship in a right triangle? What do you guys know about theta? What's the definition here of tangent? Do you guys remember? Tangent theta will be what? B over what? A. Tangent theta, B over A. So notice this. This goes back to the work we did on the first day. Is that right? Did we look at right triangles on the first day? You go, wow, I never knew right triangles had so much information and so much use. They do. So that angle theta and C, we're going to find the magnitude. Okay, you guys have all the right information there. Now, I'm going to write this down here. So here's what we're going to call, here's the definition of what's known as the component form of a vector. The component form is when you take that length there, the horizontal component in gray, which was x2 minus x1, and then you take the vertical component, which is y2 minus y1. So you have both the horizontal and the vertical. So here's going to be A, and then here's going to be your what? B. So this is how you start to define vector V, ladies and gentlemen. This is called the component form of a vector. So it's based on some arithmetic. You just take the difference of all the x coordinates. Remember, this is going to be the what? Right minus the left, and this is the top minus the what? Bottom. Right minus left, top minus bottom. There we go. There we go. The component form. Okay. So here's your first example. Okay? We're going to get the component form of this vector. So remember, your first point over here, okay? This is the first point. This is the second point. You got x, you got y. You got x, you got y. So it might be helpful for you to say, okay, x1 is 1, y1 is 2. Okay, does everybody agree with that information? Your first point? Now what about the second point? X2 is what number? What's X2? Uh-oh, how are you going to read that to get the component form? 6, good. What is Y2? Good. Look at that, ladies and gentlemen. So you're going to use the definition. Take your 6 minus 1, and that's why I have that here. 6 minus 1 will be 5, ladies and gentlemen. So A is 5. And then similarly, you have what? 5 minus 2. So you have 5 minus 2 is 3. This is your B value, ladies and gentlemen. So you identify X1, Y1, X2, Y2. You do your arithmetic. And ladies and gentlemen, sure enough, there it is. Vector V is going to be, by definition, remember, they write it this way, A, comma, B. This is a component form. So vector V is going to be A being what? 5 and B being 3. Here is the definition of vector V now. Okay, it's based on that arithmetic. 5, 3. There's your component form. You got the horizontal component, first value. You got the vertical component, second value. 5, 3. And then you might say, well, how do I use that information, right? Well, here's your 5. Here's your 3. Do you guys know, what does the Pythagorean theorem say? We're going to get we'll get C squared, which will give us C. We can get the magnitude of the vector, the length of that vector. So once you have the component form, we can find the angle and the length of your vector, ladies and gentlemen. So that's going to be what's next. But first of all, get the component form, 5, 3, and then now we can do the arithmetic. So you say, what is that? Well, let's do Pythagorean theorem, right? C squared will be what? 5 squared plus 3 squared. C squared will be what? 25 plus 9. C squared will be what? 34. What is C? And remember, the distance is always positive here, so it's just a square root of 34. Now, what I did here in the notes, this is going to be extremely important for you guys. What I did here in your notes is this. Let's wake up the TI. You say, okay, TI, square root of 34 is going to be what number? What's the square root of 34? 5 point what? 8. .8. So I approximated that to the tenths. All right, you guys see what I'm saying here? This is how I got the what? The magnitude. And that's C, okay? So if I said to you, what's the notation? The magnitude, ladies and gentlemen, we write this way. That's the magnitude. This is what they're going to look for. So I got the component form of my vector. I graphed it. I know the length. That is 5.8 units, this length here. How long your vector is. Right there, that's the length. Pythagorean theorem. How do you think we're going to find theta? The direction it's pointing to. Anybody know? Use the definition from right triangles. What's tangent theta defined to be again? Anybody want to tell me what tangent theta is? 3 over what? 5. Isn't that opposite over what? Adjacent? And then you get to use your inverse tangent. Remember inverse tangent? You guys study this stuff for a reason. You study this so you guys can use this stuff. Is that right? Let's go to the whole degree. So I'm going to go to my TI again, and I'm going to say TI. Let's make sure, first of all, you're in the mode of degrees. Looks like you are. Okay. I need inverse tangent of what number? 3 what? Fifths. What's inverse tangent of 3/5? Go to the nearest whole degree. What is that going to be? 31 degrees. So, ladies and gentlemen, you're done. Now, let's think if this makes sense here. Is this angle, could that possibly be 31 degrees? How do we know? If I said to you guys, I'm gonna create another imaginary x and y coordinate here, right? Because you guys remember, calculators aren't always perfect. Here's like this is the x-axis and the y-axis, right? Isn't this in quadrant 1? Where you have a nice positive angle? 31 degrees. So you got the length, 5.8, the magnitude, 31 degrees. And none of this is made possible if you don't know the component form of a vector being a comma what? B. Okay, you guys know what we're saying? Without that information, you can't get the length and the what? Direction of that vector. Is that true?
What are those little signs on the sides of A and B?
Oh, that's a good question. Those are like inequality symbols, but that's just we run out of symbols to describe things. So we have to rehash other symbols. So those are kind of like the arrows looking to the left or right, opening. It's different than you say to me, well, I remember parentheses represent what? A point. Is that true? So a parentheses represents a point. But these signs here, these like inequality signs, this really means a vector. This is now a vector in component form. Notation. So whenever you see that, what do you guys want to always know? This is the component form of what object? A vector. A vector is not that guy in the cartoon. You guys remember Vector? Whatever that guy was? Who was Vector? Despicable Me? Remember they got the name Vector? Yeah, exactly. And Despicable Me, that's Vector. And this is the symbol for it right there. That little like V with that arrow, little arrow on top. Vector. Despicable Me. Isn't that amazing? Isn't that funny? He said, really, I learned where they got the name from. They got the name, that's where they got the name from. When they wrote Despicable Me, they said, oh, we're going to borrow the name Vector. It's not Victor, it's Vector. It's with an E. And that's the symbol. All right. So I did put that in the notes, how you guys get that. You guys can see that, and it's very, very what? Very simple. And I summarized it all, just like I just did for you guys here. Here's a summary. So that's what I want you guys to learn. You know, given 2 points, can you write this in component form? Yes. Can you find the magnitude and direction? Yes. All from what? Right triangle information. And this is very useful. Vectors are very useful in science. All righty. We're gonna do some more here. Do you guys think you could do these two here? 1 and 2 on your own? I'm going to have you guys try 1 and 2. I want you to do what? To get the component form, I want you to find the magnitude and the what? So component form, magnitude, and what? Direction. They're going to give you, again, A is your initial point. B is your what? Terminal point. So A is the initial point. B is a terminal point. So get the component form, magnitude, and direction, ladies and gentlemen, and we'll see how it goes for you guys on this. I'm going to get out the clock. See what happens. Lucky number 8. So this is x1. This is point 1 and point 2. You guys okay with that? So you got the x coordinate and the y coordinate. So maybe you want to say x1 equals what? 0. Y1 is -2. I got the x coordinate. I got the y coordinate. Okay. What is x2, right? X2 will be what? 4. Good. What is y2 going to be? 2. Is that true? So you're going to have 2. Oops, 2. 4 minus 0. Is that true? So let's write that down. So vector v is going to be 4 minus 0 2 minus -2. Four, and what's 2 minus -2? Is that 2 plus 2? So it'll be 4, 4. Okay, so, if we plotted those points, by the way, 0, -2, this is where 0, -2 would be. This is A. 4, +2. 1, 2, 3, 4, up 2. Okay, so this would be point B. So your vector, let's do it in blue. Here's vector. All right, you guys good with that? You guys see what I'm saying? All right, you got A and B. Now, let's get the magnitude. How do we get the magnitude? I wish I had more space here. Sorry about that. Let's do c squared equals what? 4 squared plus 4 squared. Isn't that 16 plus 16? What's that going to give you? 32. So c is going to be what? Plus or minus square root of 32. And I'm going to use my vector notation. Okay, so let's get out the TI now. So let's clear that out. Second square root, what? 32. And this is about 5.7. Is that true? If I go to the tenths, let's go to the tenths here for this. So did you guys get 5.7 here? I hope. All right, 5.7. It's 5.7. Now we're going to approximate to the tenths for the length, but for the angle, we can do a whole number for the angle, right? All right. So I'm going to use, since we're limited in space here, okay? I'm going to use now. You guys have that in your notes, right? We're going to say, let's find the angle theta now. So tangent theta will be 4 over 4. Oh, I think I know what that's going to be. Yeah. If tangent theta is ever 1, we know by now theta has to be what? Pi over 4? So theta is going to be 45 degrees, ladies and gentlemen. All right. Okay, so if you forget, tangent theta, inverse tangent. So we're going to use the inverse tangent of 4 divided by 4, right? There's your 45 degrees in case you forgot there. So we got everything you guys need in this in this sheet. Looks like pretty good, pretty good. All right, so there it is, ladies and gentlemen. Let's do the same for the next one. What do you guys think we get for this next one here? Okay, what'd you guys get here? Let's see. Yeah, we're done. You got the component form right here. 4, 4. Then you got the magnitude and the direction. All the information is right here. All right, let's do the next one. All right, you guys okay with that? So now you got x2 minus x1. Let's get vector v here, okay? Maybe we'll put vector v down here. So we get -1 minus 4, and then you get the other value here, 5 minus 1. -5, what? 4. So there's vector v in component form, okay? So if you're to plot these values, let's plot them. 4, 1 now. You can see that's to the right. 1, well, if we get a pencil here. 1, 2, 3, 4. 4, 1. Here's the location of A. Okay, here's that first point, 4, 1. That's A, the initial point. B, -1, 5. That means I go to the left 1 and go up 5. So here's B. So when you draw vector A, it looks like this. Okay, now notice that's kind of pointing to quadrant 2, isn't it? We're going to have to go through some details here, ladies and gentlemen. We got to be careful here, okay? So this is a pretty good example. Component form of your vectors. Now, how are we going to get the magnitude? You guys remember? C squared equals what? Well, let's do C. How's that? Pythagorean theorem. Well, C squared. -5 squared plus 4 squared. That's going to be what? 25 plus 16. C squared would be 41. See, we're going to take the positive value for C. The length of this vector is the square root of 41. So let's find out what that is. See if you guys got this one. Square root of what? 41. 6 point what? 4. .4. Okay, you guys okay with that one? You're seeing all the information you need right here. So let's kind of take a look at the angle here, okay? And I want you guys to know something that's important here. This is when I brought up that imaginary X and Y axis, okay? the angle theta, this is the direction for theta. It's a quadrant 2 angle. It's an angle in what's called standard position again, right? So if you said, well, what is that vector doing here? Here's the vector. We need that angle. That's the theta angle here. So let's see if this is going to make sense for us. Tangent theta is 4 over negative 5. Is that right? So theta is going to be inverse tangent of what? Negative 4/5. Okay. All right. Inverse tangent. So here you go. Second inverse tangent, negative 4 what? Fifths. So what is this? Let's go to the nearest degree here. This is my point to you guys. Negative what? Negative 39 degrees. Now, you have an issue here. This is why I brought this up. Negative 39 degrees. When you give the direction, your angle needs to be between 0 and what? 2 pi. Okay? Your angle has to be between 0 and what? 2 pi here. So in this case, 45 degrees was fine in the first example. But in the second example, your calculator is lying to you. Okay? Why is the calculator lying? Because remember, if you have to use the inverse tangent, they restricted the domain. Is that true? This is a quadrant, by the way. 1. This is quadrant 2. This is quadrant 3. This is quadrant 4 in the context of what? The standard angle. So how am I going to get, ladies and gentlemen, the correct positive angle? Anybody know? Huh? What angle is this? Because they gave you here, they gave you this angle. This is what they gave you. That's negative 39 degrees. So how do I get the positive angle? You just have to add what to this? You add 360? Do you add 2 pi? $180. Good job. You add 180. You say, why? Because this is the direction of my arrow. This is my, you see the blue arrow? I need that angle. So I have to add pi to get that angle. Is that true? So you say, what is pi? 180. So the angle is going to be, you need to add 180 here. $180 minus 39. That's 141 degrees. I mean, there are 2 quadrants, this is correct, where tangent is negative. It is quadrant 2 and quadrant 4, because all students take what? Calculus, okay? However, your vector is pointing in that direction, and you can't change it. That's the direction of your vector. So the angle is really going to be 141. All right, you guys okay with that? Easy peasy, lemon squeezy. 141 The length of the vector is 6.4. And we got the component form of the vector. There's your component form over here. So we got everything we needed to get. Jeez. I don't want to draw that, whatever that is. What do you guys think? Negative 5, 4. All right. I want you to take some time to do what? Do the next two as well. See what you guys get for the next two. All right, ladies and gentlemen, should we try this again? Let's take a look here. Here's your first point. Here's your second point. Is that right? 1, 2. X, Y, X, Y. So, if X1 is negative 3, Y1 is 5. Let's make sure we have our audio, and we do. X2 would be 0, right? Y2 would be what? 6. 0 minus what? Negative 3. So we're going to put, let's use the component form of our vector here. V equals 0 minus negative 3. Okay, and then y2, which is 6, minus 5. So let's see this. So your vector V, 0 minus 3, isn't that now plus 3? That would be 3. 6 minus 5 is 1. So here's your component form of your vector. 3, 1. So plotting these, let's take a look at this. You want to go to the left. 3 units for A, the first point. 1, 2, 3. 5 units up. 1, 2, 3, 4, 5. So here's an A, and then 0, 6. X is 0, Y is 6. 1, 2, 3, 4, 5, and what? Here's your B. All right, you guys see that vector there, A to B? Easy peasy, lemon squeezy. Okay, now let's get the length of this vector. C squared is 3 squared plus 1 squared. 9 plus 1 is 10, so C squared would be 10. C will be plus or minus square root of 10. C is the square root of 10. Okay, this is about 3 point what? Is that 3.2? Right, to the nearest tenths position? 3.2. And I'm going to use the notation of C, we're going to use the magnitude notation, okay? That's the length. That's how we draw it. Okay. $3.2. Tangent theta, what's the ratio? It'll be 1 over 3. Is that right? Because remember, this is A and B. So tangent theta is 1/3. Theta is going to be what? Inverse tangent 1/3. So second, here's tangent 1/3. 18.4, 18 degrees. We go to the nearest whole degree. Okay, so this is about 18 degrees now. So, ladies and gentlemen, if it's 18 degrees, let's see if this makes sense. This is what I want you guys to go back and think about, right? If you draw this imaginary x and y coordinate, because it has to be a standard angle from 0 to what? 360. That's quadrant 1. Is that true? Does that make sense that this angle should be 18 degrees? I say yes, 18 degrees. Absolutely. So number 4 should be fine. You guys okay with that? That's all the information. Yes, question.
So the vector with the arrow, that has to be in proximity. The theta has to be whole number?
No, it doesn't have to be a whole number. It could be to the tenths, it could be the hundreds, it could be to the thousands. So I'm saying when we go through this exercise, I'm giving you the angle theta to the nearest whole number. Let's see, should we be able, can we get the last one in, you think? Let's do the last one. First point, what? Second point. X coordinate, Y coordinate. X coordinate, Y coordinate. X1 is 2. Y1 is 2. X2 is 4. Y2 is -3. So, if you want the component form for vector B, you're going to have to take the, what again? 4 minus 2. -3 minus 2. -5. So double check that we're fine here. 2 -5. Okay, there's your vector V now. So let's find the magnitude of that. That should be 2 squared plus -5 squared. 4 plus 25 would be 29. So C is the square root of what? 29. The length of V, square root of 29, ladies and gentlemen. Let's see what this is. Square root of what? 29, 5.4. Okay, we went to the nearest tenths for the length here. What about the angle? Okay, let's get the angle here. So, oh, we forgot to graph it. You guys know why it's important to graph? So you could get the angle, right? So here's point A. B is 4, negative 3. So you go 1, 2, 3, 4, and down 1, 2, 3. All right, so I want you guys to understand something here. Just from the beginning here, before we get the angle. Theta, here's that standard angle, theta. So let's find it. Tangent theta, remember, is B over A. So this is A, this is B, negative 5 over 2, which means theta will be inverse tangent, negative 5 over 2. Let's see what theta is. Negative angle. Is that negative? We'll go to the whole number again. It's negative 68 degrees. Now, it is true that this is a negative angle, right? Negative 68 degrees. Now, that makes sense. Is that true? But if we want that positive angle, what do you think we're going to have to do with this negative 68? Not add 180. Add 360. You say, why? Because you have to make sure that your arrow is pointing how? In this direction here. The arrow has to point in that same direction. So if you want that positive angle, that's going to be 360 now plus the negative angle, which is minus 68, 292. So theta is going to be here 292. Now you might say, why again? Because you really need this to be pointing where? Down. Vectors are very strict. They want it to be pointing in quadrant 4. So this is quadrant 1. Quadrant 2. Quadrant 3. They want it to be pointing in quadrant 4. So, ladies and gentlemen, this is how we get a start on magnitude and direction for your vector. You have it in component form, and I'll give you guys some homework, in Canvas. We'll see you guys tomorrow. Welcome back. Take care. Stay safe.
Why not 180?
Magnitude and what else? Direction, right? Magnitude and direction. An object with magnitude and direction. So we worked on this yesterday. We got started on these. So, ladies and gentlemen, we went through all these great details of vectors, these great examples with vectors. And this is the oddest thing I've ever seen. What happened to the rest of my what? Vectors. There we go. Let's hope it comes back. There we go. Okay. So what I want to describe this morning now is some various properties with vectors. Okay, here's some of the most important properties we're going to deal with, because vectors are a very useful tool in your science courses, which is why we want to talk about vectors. And we have some vector properties. In other words, we have what's known as like vector arithmetic. And that's what they mean by vector properties. We can perform various kinds of arithmetic with vectors. So let's dive into that to see what kind of arithmetic they're talking about that we can do, right? So, for example, if you're given two vectors, now here's the name of the vectors, and it's in the component form, right? So you got vector v here, and sometimes when I have, 2 things I use green and orange because it's convenient up there. So here's two vectors in component form. Okay? What they're going to define for us is how to do vector what? Addition. You might say, what is vector addition? Well, addition means to add. Is that right? Does addition mean to add? You say, yes, it does. So where is this addition happening? Right there. And it's happening with two vectors here, green and what? Orange. There's your two vectors. We're going to do vector addition. So that's done by adding the components. You might say, what are the components again? Well, here's A1. Here's A1. And that's kind of like the X component. Is that true? So the first portion is saying, okay, for that first position, it's kind of like the X coordinate if you want to think of it that way. Although it's not a point, that first position. All you got to do is add those values. And then for the second position, you're going to take what? B1 and B2. And you're going to do what here? Add those values. And then you're going to get the what? Y value. So this is known as vector addition, okay? You can add two vectors together. Now, what I want to share with you guys here is there's going to be a graphical form of how to do this that we're going to use later, but this is going to be our vector addition. And this is AKA, just so we know, this sum is also called a resultant vector. Now, I'll get back to the geometry of vectors later. We're just going to focus on the vector sum for now. But if you want to take a look at this, let's actually just mention it. Here's a vector in free form. It's in space. There's no coordinates there. And what we can do with these vectors is, believe it or not, we can move them around. You go, really? Yeah, we're going to see that a little later. Okay? And so here's another vector known as W. These are what's called free-form vectors. Okay? They're in free form, meaning there's no coordinates. No coordinates. We know how to do vector addition when there's coordinates, but we're going to study this free-form vector as well. And what you end up with when you add these vectors, this is called that resultant. Okay? That means it's the result when you add. So this is that vector addition. This is V plus W. So we can do it component-wise and in free form, we're going to see later. And there's a definition here about how to actually do free-form addition. Here's what this is. I'll just mention it at this moment now, just so we're complete. We can perform vector addition in freehand, free-form mode, by using the terminal point with vector V and the initial point of vector W. So you say, what are you talking about? Well, you start by reading left to right, vector V, and you say, where is the terminal point for vector V? Right? So here's kind of what the free-form version is. This is where you start, the terminal point. This point is terminal. And you start with that terminal point for that first vector V. Here's your V right in there. So you say, okay, now what do I do? Well, you match it. In other words, you move vector W. And what you do here is you use the initial point for W. It's going to be that same point here. So here is the W vector, if I can find the highlighter. And all you do is put the initial point, the starting point for vector W, and maybe I'll put that in orange here. So we're going to match the terminal point for vector V with the what? initial point for vector W. And as you guys can see, we create those two vectors. The sum will be this in blue. It'll be the initial point for V, and then the terminal point for what? W. So we're going to get back to this graphical method of, adding vectors. This is a vector sum, but we're going to introduce to you the component form today, meaning add the components. All right? So anyway, let's look at that here. You also have another form of arithmetic. What's this called? Yeah, it's called, and here's kind of what was mentioned yesterday, this idea of a scalar. Now, don't ever be afraid of the word scalar. Scalar is another way of simply saying a number. It's not a vector, a scalar. So scalar is not a vector. And we can take a number, any number, like in this case, C is a scalar. So you're taking C and we're multiplying it with V, and you say, Mr. Judge, how do you do scalar multiplication? That's what this is known as. How do we do it? Component-wise. And I'll say what we do is we take that C. Here's the vector V. Here's the first component. Here's A. Here's B, those first components. And really what you do is you distribute. Yeah. You multiply C to both of the components. So you go, does that mean now I have what? Well, it says, you know what? I have that C. I have that C. Here's the A value, and then here's the what? B value. So you're distributing, and yes, they say C is not zero, meaning you're not going to use a zero. You can use a zero, but it's going to be trivial, and I'll talk about what that is. But this is called scalar multiplication. You take a number times a vector. And then you say, well, what does that even mean in freehand, right? Well, the requirement for C is that it's not zero. But what that means is C can be what? Positive, or C can be negative. It just doesn't have to be zero. So what is the effect on scalar multiplication freehand again? We're going to look at this freehand. So here's really what the effect is, so you guys know. Here's your vector V, okay? And if I use a scalar multiple, first of all, there's 1/2. The effect is really this. Whatever magnitude vector V is, okay, half of that vector just shrunk the vector. It shrunk the vector by 1/2. So what I'm trying to illustrate to people in this picture is compare and contrast. Vector V does have a magnitude, right? And we represent it by this symbol. 1/2 of V is you're really going to take 1/2 of that. It's going to be 1/2 the magnitude now. If you said, I want to double the vector V, what do you think you're going to do now? You're going to double the magnitude. So what will happen here is you get 1/2 of the magnitude. That's going to be the length of this vector. And here you're going to double the what? The length of the vector. But notice the direction does not change. So there's no change in your direction theta. It's still that same angle. If I said, is the angle of this vector still going to be this theta? Yes, it is. So notice that those constants or scalar multiplication is not going to change the direction of your vectors. Okay, this is the effect of a scalar multiple of a vector. And, here's that V. And then over here, you say, well, what about negative values? Well, Negative values, like here, -1 here, has the effect of simply what? Changing the direction of the vector. The magnitude is the same, but this is now in what we say the opposite direction. Opposite direction with that negative value here means it's 180 degrees opposite. That's what they mean by this negative value for v here. Okay, it's still going to be the same. You're going to have the same magnitude, but the effect of taking a negative number to a vector means change direction directly opposite. So maybe I should put that word. It's directly what? Opposite, not randomly opposite. You say, what does that mean? 180 degrees opposite. So here's v, and then minus v is directly opposite by 180. And then you can actually shrink that as well. This is now, -1/3 of that. It's directly opposite. This is -3 times that v again. It's still negative, so it's directly opposite, but the length is now 3 times. So I want you guys to see this here, this picture, because when you have a negative value, it changes the direction of the vector to be completely opposite. I say directly opposite by 180. And so this is another property in freehand, but the component form, you just distribute, whether the number is positive or negative, and we're going to see that. So the third thing you can do, now that you know about vector addition, is vector what? Subtraction. And so what I did here is I gave you the component form. But we're going to see again in the future, graphically, really the effect of addition and subtraction. So in component form here, okay, we have this first component in gray, and then we have the second component here. And so notice the operation is subtraction of the vectors, and that operation will be subtracting of the components. So we have v, we have w, and I'll share with you later graphically what this means when we start to work at some of the applications graphically. So you have vector addition and vector subtraction. We're going to focus here on simply doing what? Some of these operations, okay? You guys see this here? Okay, so again, focus on the components here. So when they define vector v, here, and vector w, that sum, and I'm not going to draw an arrow. Sometimes we could draw it this way. Okay, you say, what do you mean? Well, that means vector as well. You don't have to have the arrow. So what does it mean to add two vectors component-wise? Do you guys know, what do? You take what? What number? 2 plus what? 1. We took this 2 and this 1. You guys okay with that? And then we take -3 plus what? 5. So what is 2 plus 1? 3. What's -3 plus 5? 2. So, ladies and gentlemen, you have found what? Your vector what? Vector addition. And notice this is what? 3. And over here, this would be what? 2. So you're actually just adding the components there. Okay, easy peasy lemon squeezy. All right, now, I wish I can Maybe I can cut this in, and how about this? Let me do this here. Okay? Let me go back here. If I can erase some of this here, I'm going to need to create another scratch here. Okay? So I'm going to call this here scratch. And go back here. Where are you? Where are you, vectors? There you go. And what I'm going to try to do, if I can here, let me do this here. Okay, I'm going to try to take a picture, and we'll do some work this way. So it's now in vector scratch. Let's go to vector scratch. There you are, vector scratch. Okay. And what was vector v? Do you guys remember? What was the definition of v? Do you guys remember in the notes? Because I should have brought that with my scratch. V. Yeah, how about if we do this? Can we do that? Let's do that. All right, that's a lot better. What do you guys think? So the first example again, you say, if I have to take a sum of these two vectors, again, what do? You simply add the what? You add your components. So your vector v plus vector w will be what? 2 plus 1, and then negative 3 plus what? 5. So what does that give you? 3 comma what? 2. So here's your vector what? Sum. Okay, you guys okay with that? Anybody have any question with these components here? All right, now you say, what about the vector subtraction here with components? Well, just do some what? Do some subtraction now. So you're going to take now the first component, which is what? 2, and then you're going to subtract what number? 1, and then you have what? Negative 3 minus what? 5, okay? So you're going to compare and contrast. Addition, addition, addition. Subtraction, subtraction, and subtraction, okay? This is for number 2. So you end up with now, ladies and gentlemen, what's 2 minus 1? 1, what's negative 3 minus 5? Negative what? 8. Okay, easy peasy lemon squeezy? What do you guys think? Is that easy? Okay, now what does question number 3 say? That's scalar multiple. What's 3 times v? Right? 3 times v. So number 3, you're going to say 3v. Now, what I like to do, just so you guys know, what I like to do is I do a nice, I'm going to put down my v vector, 2, -3 components. So I'm going to put next to these values, this is 2 and what? -3. This is scalar multiplication again. 3, 3. And what do we say we do with scalar multiplication? Just distribute. Is that true? So the scalar part will be 3 times the first component, and then 3 times the what? Second component. Okay? So let's see the components so you guys can see my point here. Okay, you guys see this with colors? You guys see my point? So what does the arithmetic give us now? 3 times 2 is what? 6. 3 times -3 is negative what? And there you guys go. This is your what? Scalar multiplication. It's pretty simple. It's just based on some what? Arithmetic. So those are like the 3 main operations: addition, subtraction of 2 vectors, scalar multiplication. What does number 4 say? You're going to take the scalar of a -4, but you're going to multiply it with what vector now? Vector w. Okay? So you say vector w. Okay, vector w. So I write this down as -4 times vector w, scalar multiplication. I need to know what vector w actually is, though. What is vector w in our example? 1, 5. Is that true? So it's 1, 5. So here's going to be scalar multiplication. So with this scalar, what do? I distribute. -4, 1. -4, 5. And then you end up with what? -4, comma, negative what? -20. So I want you guys to see some of this graphically. And let's give you guys, let's highlight these answers. Answer, 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 and what? Answer. All right, you guys okay with that? Easy peasy, lemon squeezy? All right, let's look at number 5 now. You say, can I do more arithmetic? Yes, they want us to do 3v minus 4w. So let's write down number 5, 3v minus 4w. So I would say to you guys, take a look at this kind of arithmetic. I love that about vectors, meaning v is defined to be 2, -3. W is defined to be 1, 5. 2, -3, 1, 5. So what you want to do is do your what? Your scalar what? Multiplication with your vectors. So this becomes 3 times 2 times, that's that 3 with the first component. 3 times that negative 3, the second component, minus 4 times 1, and then 4 times 5. So you're going to distribute with your scalar multiplication here. All right, you guys see all the details here? Does the colors help? Okay. Colors help. Okay. There you guys go. What do you guys see? So with this information, you now have, let's get this pencil. You may say, Mr. Judge, we already did these calculations here. And I'll say, I know. So this is your first step. You guys just did what? Scalar multiplication. Now, you might say, what do I do with these components now? Well, what's your operation now? Subtraction. How do you do that? You do that component-wise. So get those components. 6 minus 4, negative 9, minus 20. Here's your subtraction. Six minus 4 is 2. Negative 9 minus 20 is negative what? 29. So, ladies and gentlemen, here you go. And there it is. So I want to share with you guys that there is a way to do some arithmetic with vectors, and it's very meaningful. All right? Now, anybody have any questions with what we just did with these vector arithmetic questions? Is that easy peasy, lemon squeezy? All right, so now you say, okay, Mr. Judge, I got some new vectors here. What comes next? Well, what I put in the vector, I should say what? Notes. Is they're going to want you to do what with these new vectors? What does that say now to do? All of these vectors we just found. We got new vectors here when you did vector arithmetic. They want you to now find the magnitude and direction. Well, it says determine the magnitude of those. And, it should be magnitude and direction. So let's change that here. Magnitude and direction of these new vectors. How do you think that works? Right? So if I said to you, go back now with the scratch, you see that vector sum? Here's the new vector here. This new vector is 3, 2. So what I'm going to do here now is I'm going to copy this. And I'm going to now say here, without bringing that other stuff in, what is the magnitude? And your direction for that vector sum. And that's question 6, or example 6 here. Since we already know the components of the sum of these vectors, 3, 2, didn't we get that up here? So that's 3, 2. So what I'm going to do here is I'm going to bring in your graph here, because I want you guys to see something extremely important. At least for now. What did we do yesterday? Do you guys remember what we did yesterday? Didn't we graph these vectors? What I want you guys to know here is that this is like the x-coordinate and the y-coordinate on your Cartesian coordinate system in the graph. They didn't say graph this, but I want to show you guys the vector. So when you see this, this is thought of like yesterday as your A value and your B value, 3, 2. How do you draw a graph of the vector? This is a graph. You know what you guys do? Where would the point 3, 2 actually be? You go to the right 1, 2, 3. You go up what? 2 units. So this is the address of 3, 2. Okay? Isn't that kind of what we did yesterday? But this is a vector, and you say, how do I know it's a vector? You guys see these what? Those lines. That's the vector notation. You guys asked that question. So draw your line now this way. Draw your arrow. Your initial point is the origin. The terminal point is the address 3, 2. So this is the graph of the vector. Notice it's being pointed in quadrant what? 1. Is that true? All right. So could you guys now tell me, because they want to know, and I have a typo here. This is the vector sum. Sorry. There's a typo. That's the vector sum. I apologize. We need to now find the magnitude. In other words, they want us to find the length of that vector. This is the notation. What is the magnitude? Okay, this is magnitude. And what did you guys learn yesterday? How do you get the magnitude of a vector? You use Pythagorean theorem. Is that right? This is 2, this is 3, and this is C. But Pythagorean theorem is going to be done very simply, the C value. So all you got to do now, ladies and gentlemen, is take the square root of 3 squared plus 2 squared. So this is actually C from yesterday. Is that true? So the magnitude is going to be now what? This is the square root of what? 9 plus 4, which gives you the square root of 13. So you could get the length of that vector, and this is the answer that's symbolic, square root of 13. But if you said, what is the numerical representation? Well, how do we get that? Do you guys remember? Second square root 13, we're going to have to approximate. They don't always tell us where to approximate. We're going to approximate here to the nearest tenths. And you get 3 point what? 6. So one of the reasons that you actually add vectors is going to be eventually to find what? The magnitude and direction of the new vector you got here, in this case a vector sum. So ladies and gentlemen, that new vector 3, 2, as you see here, is represented this way. You got the magnitude being 3.6, and now we're going to find the direction. So how did we find the direction yesterday? Do you guys remember? Tangent, is that right? So yesterday you say, okay, I need tangent theta to be what? Wasn't that B over A? So in this case, tangent theta is going to be what? Your B value is 2 and A is 3 for this vector. 2, 3. Again, inverse tangent. We studied this stuff. This is why we did what we did. You guys had a test on this, right? And make sure it's set to what here? We're going to go to degrees here, okay? Let's check our mode. Oh, we're not in degrees. Let's go to where? Degrees. Okay. So inverse tangent now of 2/3. And what do you get now? Let's go to the nearest whole degree. 34 degrees. And there it is, ladies and gentlemen. It's a 34-degree angle. Now, let's see if this makes any sense. Does this make sense? That the quadrant 1 angle should be 34 degrees? The answer is what? Yes. It's a quadrant 1. So what we did yesterday by finding magnitude and direction, we get to also do today, but this time it applies toward what? The new vectors you got based on your vector arithmetic. So we get to find the magnitude and direction of v plus w. We get to do it for v minus w, 3v, negative 4w, and so on, okay? Find the magnitude and directions of your new vectors. Now, what's the new vector for the difference for 2? See this here? It's 1, negative 8. This is your new vector for the second question. So 1, negative 8. In my notes, that's 7. So I said, okay, what is that? We need to find the magnitude and direction of this new vector. 1, negative 8. And again, this is the a value. Maybe I put it in red so you can see that. And this is the what? This is your b value. So this is why we did what we did yesterday. Graphically speaking, and I don't know, sorry, let's do this again. I'm not sure if I like that graph I have here, but see if I have any, oops. Maybe, will this one be better, I hope? I hope. And really, if you guys don't know, this crease is not our friend. So if we had to sketch the graph of that vector, 1, negative 8, where is that going to be? Do you guys know? You got to know where 1 is. That's to the right. And then down 8 units. So you go 1, 2, 3, 4, 5, 6, 7, 8. So start by thinking of this as a point. It's not. It's a vector. So you start by plotting 1, negative 8. That's your terminal point. Your initial point will be the origin. So you say, oh, there's my initial point. Draw your what? Draw your arrow. There's your vector. And here's the address 1, negative 8, but the arrow represents your vector. You guys see that there? There you go. What do you guys notice? What quadrant is this in? 1, 2, 3, and what? 4. So let's see what we get now. Now let's get the magnitude, okay? So the magnitude of these vectors, again, will be the square root of what? A squared plus B squared. That's really Pythagorean theorem. Is that true? So what's your A value? Is it 1? What's the B value? Negative 8? One squared is 1. Negative 8 squared is 64. This is the square root of 65, ladies and gentlemen. Let me write that better. Let's see what this is approximated to the what? To the tenths. Square root of what? 65. What do you get? 8.1. Is it true? So your vector is about 8.1. Okay, this is your what? This is the magnitude. You guys okay with that? All right, what about the definition of what? How do we get the direction again? Tangent theta was, or is defined to be B over what? A. So my tangent theta, what's our B value again? It's negative 8. Is that true? A is 1. So it's negative 8 over 1. And that means by using the inverse function, it's really negative 8, right? Let's see if the calculator gives us an answer that makes some sense. So in the TI, we say what? Second inverse tangent, negative 8. Use the negative key. Don't use subtraction. That's negative what? Negative 83 degrees? If we go to the nearest whole degree, it's not even a whole degree, integer degree. Does this make sense? Is that a negative angle? What they're saying is if I can get a pencil, this is negative what? Oh my gosh. This angle is negative 83 degrees. So that does make sense. We can use that, or, we can use the positive angle, but it makes some sense. That's negative 83 degrees. So we can leave it like that. That's fine. Or we can convert it to a positive angle if they said we only want 0 to what? 0 to 360, but that's okay. We can have negative angles. All right. What's the next vector? 3v, 6, negative 9. 3v, 6, negative 9. So in my notes, 3v, component-wise, is 6, negative what? 9. Weird. Oh, I think it's not tight here. Okay. A, B. How do we get, ladies and gentlemen, the length here of 3v? Square root of what? 6 squared plus what? Negative 9 squared, which will be 36. What's 9 squared? 81, which becomes? What is that? 7. 117. Can we approximate this? Let's go to the tenths. Let me scroll out so you guys can see everything. Second square root 117. 10.8. Tangent theta will be b over what? Right, so let's write this down so you guys can see it. 10.8. Tangent theta is going to be b over a, which means it's negative 9 over what? 6. Theta is going to be that inverse tangent. We can reduce the fraction, but since we're going to use our calculator, we can do that here. Let's see here. Let's see this. Second inverse tangent, negative 9 divided by 6. What's the angle? So the nearest integer, it's negative 56 degrees. Now, you said, but Mr. Judge, we don't know if this makes sense. So then what should we do to figure out if it makes sense? Bring in the what? Graph it. Six, negative 9. So you're going to go to the right, what? 1, 2, 3, 4, 5, 6. Go down 1, 2, 3, 4, 5, 6, 7, 8, 9. You got your initial point here, 0, 0. You get to sketch your what? There's your vector. So the fact that the angle here is what? Negative. That does make sense because the vector is in what quadrant? Vector's in quadrant 4, isn't it? Quadrant 1, quadrant 2, quadrant 3, 4. It does make some sense. So we're good with that one. So I want you guys to take a look. Yeah, we can find the magnitude and direction of all those vectors. Now, vector 9, or number 9, we're going to have to do minus 4w here, which is negative 4, negative 20. Minus 4w, negative 4, negative 20. So let's take a look at what's happening here, right? So if we want this magnitude, and maybe at this point here, if you guys know, my graph here, I don't know if I go as far as negative 20. Okay, I'm looking for another graph. All right. Here's what I'm going to have to say. If I had to do negative 4, negative 20, what's the deal? Do you guys know? If we plot that? Maybe I don't even have graph paper. And yes, I have to sketch. Let's sketch. Where's the point negative 4, negative 20? I'd have to go to the left. And then I'd have to go down how many units? So I'm just going to sketch this idea here, okay? Let's pretend -4, -20 here. There's your terminal point. Your initial point is the origin here. So there's your vector. It's in quadrant what? 3. Okay, you guys okay with that? Maybe I have to highlight it in blue. Okay, you guys good with that? Let's get the length of that vector. You say, how do I get the length of a vector? I'm going to put my notation. Okay. Square root of, what are the components? -4 and -20. So I'm going to take the -4 and square it. Add the -20 and square it. Okay. So I can do some arithmetic. This is going to be 16 plus what? 400, which becomes the square root of 400 and what? 16. Okay. Now that's the length. I'm sure we can simplify this, but we're going to get the numerical answer. Meaning, let's find out what this is in our calculator. Square root of 400 and what? 16 gives you 20 point what? 4. So this is the magnitude, ladies and gentlemen, of this vector. Because you got the components here. Components go in here. What's the direction? Use the definition. Tangent theta is B over A. You say, what is B and A? Oh, here's going to be our what? A and B. -20 over -4. Which means tangent theta is +5. Theta is inverse tangent of 5. So in our calculator, here we go. Inverse tangent of what number? 5. What's this as a whole number? 79 degrees. Good job. Now remember, what's the whole point of graphing your vector? Do you guys know what I mean by that? Yes, we got 79 degrees. What's the whole point of graphing this vector? Yeah, you got to find the correct angle. That's your angle theta. Is that 79 degrees? Absolutely not. So your calculator can't be trusted. Okay, so what you got in the calculator here, believe it or not, is this. Your calculator gave you this what? Angle. You can't trust your calculator. See, your calculator is wrong. And you might say, why was it wrong? Because we know what? All students take what? All students take calculus. Tangent is positive in 2 quadrants. So you're going to have to make sure you have the right angle. And I got to change my language, not a right angle, the correct angle. Anybody know how am I going to get that? I have to add what? Aren't they directly opposite? What do I have to add? I'm trying to get the red marker. 180, is that right? So take the 79 and add 180, which is pi. That's now going to give you the answer we're looking for. What's that going to be? What's 180 plus 79? Is that 259 degrees? Double check. I haven't had my second cup of coffee. I'm not even awake. Is that going to be 259? Isn't 259 in quadrant 3? So, ladies and gentlemen, I'm going to write that down here. This angle is 259 degrees. Easy peasy, lemon what? Squeezy. So don't trust your calculator. Make sure you graph the vector. Even if it's just a sketch like I just did here. Because the point of this is to simply do what? Find the correct quadrant the angle lives. Calculator can't be trusted. So the last one, number 10, in those notes, by the way, is what? This new 3v minus 4w was 2 negative 29. So we're going to have to find the magnitude and direction of this vector as well. 3v minus 4w is what we see here, negative 2, negative 29. 3v minus 4w. Okay? So if you guys like, you might say, hey, Mr. Judge, that's a lot of arithmetic. Can I still use my calculator? Yes. You know what you can do? You can say square root now 2 squared plus, put in parentheses, negative what? 29 and square that. What do you guys think? What's it going to give you? What's your answer going to be? To the nearest tenths. Let's go to the tenths. Isn't that 29.1 degrees? Is that true? 29.1 degrees, ladies and gentlemen. Easy peasy lemon squeezy. And then you might say, what's the angle? And I say, uh-oh, we better sketch this. Before I do that, I could get the angle. Tangent theta isn't that negative 29 divided by 2? Right? B over A? Which means my angle theta would be inverse tangent of what? Negative 29 divided by 2. All right, what's that going to be? Let's get out our calculator, okay? Second, inverse tangent, negative what? 29 divided by 2 gives you what? Is that what's this to the nearest integer? Is that negative 86 degrees? Did you guys see that there? Okay. However, let's see if this makes sense, because we have to graph this vector to negative 29. So I'm just going to sketch it. I don't have to get a fancy graph. Because I just really have to see what quadrant this lives in. Is that right? So plot the point now. You say, what do I plot? You plot the point to negative 29. So that's to the right 2, and then down what? Right? To the right 2, down 29 units. This is just a what? A rough sketch. there's my arrow. So I plot 2, negative 29. And maybe I'll emphasize the vector. If it lets me. Okay. What quadrant are we in? 1, 2, what? 3 and what? 4. Is that quadrant 4? Oops. Oops. In fact, I have to learn how to graph. That's not 2, negative 20. That's negative 2. Sorry. I got to get that coffee in me. I just found out the other day my wife's been only giving me 1 cup. Huh? She probably snuck some decaf in there too. Isn't that horrible? Say, Mr. Judge, that's horrible to blame your wife. Well, she has. It's true. She has been putting some coffee there. And I found out it was only 1 cup. So I'm like, is that why I'm making all these mistakes so early in the morning? Let's see. Does this make sense? Now, this is the point. What? 2. Negative 29. Does that make sense to have a negative angle like negative 86 degrees? Sure does. So we're good. What do you guys think? You could leave it as a negative angle like that. That's fine. So the point I want to make to you guys is we can do vector arithmetic, and it's extremely important to do that. Okay? And that's in our worksheet. In fact, this is what I wanted you guys to do here in our notes with that one vector. Of course, they'll give you, different vectors on your homework. I just want to mention a few things here. Here's a definition. There is a 0 vector. You say there's a 0 vector? This is the definition of a 0 vector, because we're going to use some of this as well. See that 0 with that line? I guess I should put the arrow. Sometimes I put the arrow there. But yeah, doesn't matter. You can put that straight line. We call this the what? The 0 vector, okay? What are the coordinates for the 0 vector? 0 what? So you can't even graph that. It's kind of, you can't draw an arrow at the origin. But that's the definition. This is called the what? 0 vector. Isn't that interesting? And then I want to leave you guys with some important vector properties here. If I said to you, what in the world are these properties? These properties are extremely important in a lot of ways. It's kind of like numbers, right? You see that first property? And by the way, when they bold this typeset, that means vector. Because you go, Mr. Judge, I don't see these lines. You've been putting lines like this, right? Where are your lines indicating vector? Well, it's when they bold it that way, there's a history behind typeset. Bold means vector. Whatever. This is old school. So you see these bolded symbols. That was code for vector years ago. So what you're seeing with this first property is called the commutative property, meaning if you add your vectors in different orders, it's still the same answer. It's kind of like commutative for arithmetic, right? 5 plus 2 is the same as 2 plus 5. So that works for vectors as well. The next property is called the associative property, by the way. Yeah, when you group 2 vectors together, like v plus w, and then you add u on the left, that's the same as just grouping the first 2, u plus v. In other words, that's the associative property. So associative property works with numbers too. Right? Like if I said here, take a look at numbers. Five plus 3 is the same as 3 plus 5. I said 2, 7, 9, 2, 7, 9, and you added those numbers, if you add the 7 and 9 before you add the 2, that's the same as saying I'm adding 2 plus 7 first and then adding 9. And then you have what's called the identity for addition, right? So let's say this is 5 plus 0. Doesn't that still equal 5? That's the effect of the 0 vector, so you guys know. And then one of the reasons why you have the definition of the 0 vector is down here, because if I said, what's 5 minus 5? Isn't that 0? It's really 5 plus a negative 5. Well, that's still 0. So the properties that you guys know and love associated with addition now are really at play. That's all they want to say. And then you got some length of a vector here. If you take the magnitude of CU, then that's the absolute value C times the length of U. I usually prove that. I won't do that today because of time. And then you have some properties for multiplication by a scalar. So these are, properties that work with numbers and vectors. And I guess we'll give you the definition now of something that's extremely important as well. Right? If you have any vector AB like this, you have a special vector known as the unit vector. What's a unit vector? Any vector whose length is what? 1. These are unit vectors. So if you have a vector whose length is 1, we call it a unit vector. Unit being the number 1. Okay? Definition. Now you say, how do I know? Because I said these are examples of what? Unit vectors. How do we know these are unit vectors? Okay? You guys know how we know these are unit vectors? Let me share with you guys. Isn't this what? A and B? 1 over the square root of 2 squared plus 1 over the square root of 2 squared. You know what that equals? What's 1 over the square root of 2 to the second power? Isn't that what? 1/2. Same thing for the other. Guys see what I'm saying? This is why it's a unit vector. What's 1/2 plus 1/2? So we get the square root of what? 1. What's the square root of 1? So what do we call this vector? Since the length of that vector is 1, this is called a what? This vector is a unit vector. Any vector of length 1, they're kind of special because it's unit vector. And then you have this vector, and I know it didn't come out in the typeset. That's a letter I, by the way. This vector has a length of 1 as well. So you say, how do I know? Well, we called this vector I 1 squared plus 0 squared. Isn't that 1 plus 0, which is what? 1. What's the square root of 1? Oops, I forget my notation. So this vector known as I is a what? It's a unit vector as well. We have another vector called what? What is this? J, and that's another typo. I got to fix this. Sorry, ladies and gentlemen. Can't even give me a pencil. Can you give me a pencil, please? That's J. So you say, how do I know that J vector is a unit vector? Square root of what? And that's supposed to be, here's the typo here. 0, 1. 0 squared plus 1 squared will be what? That's also 1. And then the last vector, this one we call W. We got to get rid of this here. Another typo. I got to clean this up, so I will, because I plan on using these notes for a while. As long as they let me. Let me see if this is really true. Let's double check. Okay, you guys see what I'm saying? Is that a unit vector? Anyone know? Isn't this 9 over 25? And this will be 16 over what? 25? What does that mean? I'll have to do the work here. Same fractions. What's 9 plus 16? These are like fractions. What's 25 over 25? What's the square root of 1? So sure enough, the length of what? 1 here is, or the length of W is 1. This is the W work. Hard to see. All of these have a length of what number? 1. All of these vectors. All the algebra and the work is what you guys see here. You have it in the video. So this is what I want to share with people, these examples that anytime you have a vector, that length is 1, we call that a unit what? Vector. Some typos. Okay, so these unit vectors are very, very important for us. Now, what I did here, ladies and gentlemen, in your notes, or not in your notes, in the assignment portion, I did assign homework on what here? On vectors. You guys see this 8.4? This is all our homework on vectors, so I'm giving it to you all now. So you guys want to get started on those vectors ASAP. What do you guys think? Is that pretty simple? I think vectors are fun. Vectors are easy. Get started, because we're going to use some more tomorrow. And take care and stay safe, ladies and gentlemen. Have a wonderful day. On your homework as well. So we say we can write any vector. So let me go back and remind you guys, we had some very special vectors yesterday. Let's go to our Scratch. We have some very special vectors we gave you guys yesterday, special unit vectors. Right? So we have some very special unit vectors. The definition is I, the vector I, which is 1, 0, and then another vector is 0, 1, okay? So you got these special vectors, special unit vectors. And yes, the magnitude of that vector is 1, and the magnitude of the vector j is also 1. This is why we call them what? Unit what? Vectors. This is why they're called unit vectors. So if you were to try to graph these unit vectors, by the way, here's the graph of them. I'm going to do imaginary, x and y axis. This is here. Oh, let's do some colors maybe. Right, let's do maybe like green. Okay, and then we'll do orange. Here's your green. Here's your orange. Oops. Yeah, come on. Right, so we graph these vectors. So just to kind of point out to you guys again, how do you graph that? Well, you plot that point. This is your terminal point for vector I. And then vector j, the terminal point is 0, 1. And then your initial point is 0, 0. Okay, so you're looking at the address, and this is really a very special thing. You got vectors I and vectors j. Okay, so maybe I'll do this here. And there you go, ladies and gentlemen. So here's the deal. Now, here's going to be a fact that I put in the notes. Okay? In the notes, under vectors, if you're given any vector v here, right? We can write them in terms of your unit vectors I and j. So I want you guys to pay attention to that. Here's the A component. You write it as AI. Here's the B component. We can write it as plus bj, where I and j are the unit vectors I just described for you guys. This is an extremely important fact. So writing these vectors in terms of ij vectors really is preferred because of the fact that it's a lot easier to work with. Okay, it's a lot easier to do what we call vector addition, vector arithmetic. The ij vectors, it's done like you did with algebra. And so I can prove to you again on the scratch, I can say to you, why is that the case? Well, let me show you guys where it comes from, right? When you have a vector given to you as AB, what we can do, since we know about vector addition component-wise, I can split up that vector into two. So when you're given these ABs, we can split it up. Now, remember, we can pull out or we can multiply a vector by a constant. It's almost like just saying I'm factoring out the constant A and the constant B here. So you have this A all along here, and you have this B all along over here. And what you should identify really is that this is the definition of the I vector, and this is the definition of the what? J vector, right in here. So what I'm proving to you is that this becomes AI plus B what? J. Here's vector B. Where you have those components here. So here's the A component. Then you have the B component here. Easy peasy, lemon what? Squeezy. Okay, ladies and gentlemen, this is your vector V. There we go. AI plus BJ. All right, now I'm going to give you guys some facts. I want you guys to note here, still, the magnitude of v doesn't change. It's still going to be what? The square root of a squared plus b squared. And the direction of the vector doesn't change. It's still going to be b over a. All right? So in these notes here, everything is still the same. That's still vector v. It's just we write it as ai plus bj. This is what I just wrote down. And then I'm going to actually do something here to remind you guys. Here's another way to write this. Okay, we see a few things here. Let's recall, if I said to you guys remember the definition of what? What's sine theta? Opposite, which is b, over hypotenuse, which is the length of v. Is that true? And then what is cosine theta? Adjacent, which is a, over the hypotenuse, which is the length of e. So I'm going to copy this here because this is also important. You see, I can solve for these variables. I can solve for b, and I can solve for what? I can solve for a. Now you say, how do I solve? Well, multiply both sides by the length of v. You're now going to get b equals the length of v sine theta. You're going to get a equals the length of v cosine theta. So what does that mean in terms of vector v now? I can substitute those values right in here. For a, you say, what is a? Well, it's the length of v cosine theta. B, it's the length of v sine theta. Okay, so I want you guys to see all of that right here. So now, vector v can be written as, you say, how do I write it? The length of v cosine theta I plus the length of v sine theta j. Okay, so we're going to go from here to here. Now, this is what we're going to work with today, okay? And I'm going to color coordinate this because it might help some people to see everything. Okay, so we have these very important ways to describe a vector. Now, that was summarized right here. Okay, so I did the same thing here in the notes, so you guys can see what I'm saying. Here's vector AB, so we write this in terms of what's called the horizontal and vertical components. Okay, so you got this horizontal component and vertical component. That's what I just proved to you guys. And that's why vector I and j are so important. Now, you say, how do I begin the following here, right? So the instructions here are to write the following vectors in terms of I and j, determine the magnitude and direction of theta in whole degrees. So when you guys see a vector written this way, 3, 8, this is vector notation, is that right? They want us to write it in terms of the I and j vectors right here. So you might say, well, how do we do that? Well, you do it this way. You say, this will be what? 3i plus 8 what? 8j. So I want you guys to see, let's get the highlighter. Here's that 3, and then here's what? Here's the 8. Okay, so very often, all you're saying is vector v equals what? 3i plus 8j. Is that easy peasy, lemon squeezy? And of course, we went over the magnitude and direction last time, so you guys would actually do that. The work you did last time, right? The work we did yesterday. And there it is. You just write this in terms of I and j. This is a lot easier to work with. What would this second vector be if they give you negative 2, 1? How do we write that in terms of I and j for number 2? We just say negative 2 what? I plus 1 what? J. Is that right? Which is also known as just being j. So we're going to use again these values here. There it is. What about number 3? Vector v will be what? 6i minus what? 4j. Negative 4, and then what here? 6. So what about number 4? How is that going to be? You say, is that 0i plus 2j? And, well, we're going to write it just as, this is why we actually care about this kind of notation. Let me share this with you guys. 0 times I is going to be really what? 0, is that right? So this is sometimes just written as just 2j. So you get negative 5i minus 2j. Vector v, 1i minus 1 what? J. Okay, 1, here's the 1, and then you got the negative 1. Okay, and then you say, can I write this simpler as well? Yeah, we can say here, vector v is going to be simply what? I minus j. And then over here, we didn't simplify this one. Negative 2i plus j. Okay, you guys have any questions on those? And then you say, well, what about this last one here? Well, this is going to be, vector v is going to get written as what? 6i minus 4 what? Minus 4j. There you guys go. Here are your vectors in IJ form. Okay, is that easy peasy lemon squeezy? Okay, well, what about these here? You say, well, what about this? How do we write these vectors in terms of I and what? J. How do you write these last two vectors in terms of I and j? Let's take a look here. So you got the length of v is 4, and the angle for theta is 30. So let's write down what this is. Remember, v is the length of v cosine theta. This is the horizontal component. Plus the length of v sine theta j. This is the vertical component, okay? Okay? So if they told you here that the length or the magnitude is 4, what do you think we do here? We put a what? A 4 here. A 4 here. If they told us the angle for theta is 30, then what do you do here? 30 degrees and what? 30 degrees. Okay? So let me do this here. I'm going to go to the scratch because let's go through the details here, okay? Let's go to our scratch now. So you guys can see here, vector v is really going to be what? 4 cosine 30i plus 4 sine 30 degrees what? J. Okay? Is that right? All right. So do you guys happen to know what is 4 cosine 30 anyway? Anybody know? I'm going to get out. What am I going to get out? Do you guys know I'm going to get out here? Ti. Is this in degree mode? It is. So 4 cosine 30 degrees. What's that going to be? And then we need 4 what? 4 sine 30. What's that going to be? Let's go to the tenths here. You guys ready? So the first vector, the horizontal component's going to be to the nearest tenths 3 point what? 3.5i. And then what is 4 sine 30? That is 2, but it's going to be 2 what? 2j. So let me point this out to you, the details. You got 3.5i, and you have what? Plus 2j. And now, ladies and gentlemen, this is what they're looking for. This is vector v in ij form. So what they're going to want you to do is use this horizontal. This is the horizontal component. And the vertical component form to write it in terms of ij vectors. And this is a lot more easier to work with. Okay, you guys okay with that one? Is that easy peasy lemon squeezy? So I'm going to erase this. And what I'm going to do now here is this for you guys. I'm going to ask you to do this again. Well, do this yourself. Scratch. Did I bring it into the scratch, I hope? No, I bet you I put it in the wrong one, but guess what? Yes, here, I'm going to get this. I'm going to cut. And I'm going to put it in your scratch here. So this is question number what? 8. Okay, here's 8. So I'm going to give you guys some time to do 9 through 13. You get to use your calculator. I know I only did one example, but okay. It's not that difficult, but try this out. We'll give you guys some time here, okay? And I want you guys to approximate the values to the what? The 10th position. First decimal point, okay? And we'll give you guys some time. Let's get out the calculator here. All right, so ladies and gentlemen, let's take a look here. Let's try these out ourselves, okay? So remember, you're going to use the horizontal vertical component form when you're given the magnitude and direction. So number 9, what's the magnitude in number 9? Do you guys see it? So you say the magnitude for number 9 is what? 25. Is that true? So you should plug in what? 25 for the magnitude. Okay, what's the angle though? 100 degrees, is that right? So you're going to plug in 100 degrees. So vector V is 25 cosine 100 degrees I plus 25 sine 100 degrees what? J. Okay, you guys okay with that?
It wouldn't be wrong if I just put 25 I cosine 100, right? It's not gonna be a
Well, the order in which you multiply doesn't matter, but I would try to be consistent with what's traditionally done
Okay.
and not make up my own, way to do things. But the order in which you multiply doesn't matter. It won't be wrong. It's just not written down that way. Let's double check. Let me show you what I mean by that, right? So you're going to now go to the TI here. And so we're going to have what? 25. Is that right? 25 cosine 100. And then 25 what? Sine 100. And what do you guys get now? Maybe we should take a closer look. Oops, you guys haven't been seeing what I've been entering. But okay, you can see part of what I've been entering. I want you to see all of that if you can. Okay. So what is this going to be now to the 10th, right? Your vector is going to be negative what? 4.3i plus 24.6 what? J. So there you guys go. And so here's my point again. This is that A value. And this is that what? B value. Here's your I, here's your J. Okay, so here it is. That's the vector you're looking for. Anyway. Maybe we'll just block it out that way. Okay, did you guys get that for number, what was that, number 9? Oops. All right, easy peasy. Number 9. Number 10 now. What's the magnitude for number 10? Square root of 3. What's the angle? 135 degrees now. So what we're going to do now is we're going to change those values. So the magnitude is the square root of 3. The angle is 135 degrees. Oh my God. Okay, so let's plug that in now. And we say vector V now will be the square root of 3 cosine 135 degrees. There is I. Plus the square root of 3 sine 135 degrees J. Okay, so let's go over to the TI. Let's go to the calculator now. I'll clear that out. Second square root 3. Okay, maybe you guys need to see everything in the calculator. Sometimes that's helpful. Second square root of 3. Clear. Second square root of 3. Cosine what? 135. Hit enter. Second square root of 3. Come out of there. Sine what? 135. Close that too. So what do you guys get? Let's go to the tenths again. Vector V is negative 1.2i plus 1.2j. Is that true? All right, so I want you guys to see that here. Oh, whatever. Here's your I vector. Here's your j vector. 1.2. Look at the components. Horizontal, vertical components of this vector. Number 10. Good job. Okay. All right, you guys okay with that one? Did you guys get those? We're now going to look at number 11. What's the magnitude here? 200, and the direction is what? Negative 60. So we're going to change those values here now. 200 and negative 60. All right. Oh my God. Negative 60 degrees. Okay. So here we go. (200 cosine negative 60 degrees) plus 200, don't forget the I vector, 200 sine negative 60 degrees J. Okay, let's go to the TI calculator now. Okay, let's see every detail. 200 cosine negative what? 60, okay. Make sure you put the negative sign, hit enter. 200 sine negative what? 60, close that and hit enter. What do you guys get now here? Do you guys know what you got? What is vector v now? That's going to be what? 100i minus 173 point what? 0.2j. You guys go. And that's number what? 11. Easy peasy lemon squeezy. Number 12 here, okay? What's the magnitude for number 12? 1. What's the angle? 225. So let's change all those values now, right? So I'm going to say the magnitude would be 1. 1, the angle is 225 degrees. Okay, so let's look at number 12. Vector v. 1 times cosine. What was the angle again? 225. I plus 1 times sine 225j. So you guys know you don't even have to do what? One times anything is itself. So make life easier for yourself by using that information. Right? Cosine 225i plus sine 225j, okay? These are the ij vectors here. Cosine 225, close that. And then say sine what? 225. Let's close that. What do you guys end up with? What is this going to be? Negative 0.7 what? I minus negative 0.7 j. Going to the tenths. There's your vector v. Easy peasy lemon what? Squeezy. Now, what I'm going to do here for you guys is this. I'm going to take a look at the next portion on this sheet here. Right? Because you might say, I want to let you guys know something. Why do you even care about what? The ij vectors. Take a look at this next kind of question. They're going to say, determine the what? The resultant vector. They're giving you guys now two vectors here. You got vector v right here, and you have vector w right here. And they want to know, hey, can you give me the resultant vector? Now, let's give you the definition of the resultant. You know what the resultant vector is? It's simply when you add your vectors. So I'm going to write that down. Add what? Add the vectors. And let's do it in a way where we can actually see the words add, right? That's going to give you the resultant vector. Just adding them. Now, the reason the ij form is preferred is because if I write it down for you guys this way, right? If I said to you, if I can ever get a pencil when I want one, vector v is what? 4i minus 2j plus 2i plus what? J. So let's kind of emphasize this for you guys here. Here's the first vector. Here's the what? Second vector. And what are you supposed to do? Add them, and that's called the resultant vector, to do some addition. So now you might say, well, what is that going to be? Do you guys remember beginning algebra? Combined like terms. What do I mean by that? What terms are like? The i's. You guys see what I'm saying? Here, 4i plus 2i gives you what? Good job, 6i. You are combining like terms. And then you got minus 2j plus 1j. There's a 1 here. So what is that going to be? If I owe two bananas and I have one banana, isn't that minus 1 what? Minus 1j, or we should say, oops, let me go back here. Let's call this R resultant vector. I apologize, resultant vector. So the resultant vector will be 6i minus what? J. So I want to share with you guys that there is a way for you to do what? Just add your vectors. This is why you prefer the ij form. Because when you add vectors and get that thing called what? The resultant vector. Let's put R for resultant. And you could do that, find the resultant vector all day long. This is for number what? 14. The resultant vector for 15. You take V and you add it with W here, okay? So you say, well, what is V anyway? It is positive 3i plus what? 5j. There's V, and W is negative what? 6i plus 2j. V plus W. It's not negative 3. Is there a negative there? Well, I see what you guys, where you're going with that. You did the addition. So what do you guys get? Yes, combine like terms. Negative 3i minus 6i, you're right, will be a what? negative 3i, and then 5j plus 2j gives you, what does that give you? That's plus what? 7j. And there's your resultant vector. So this is why you care about the ij form. All right, you guys okay with that? 14 and 15 here? And I'm going to skip down to number, well, let's do 16 here. Let's get the resultant vector. So you're going to take vector, what is this? Negative I plus 6j. This is vector v plus vector w. That's minus 4 what? J. So what happens when you add those two vectors? Isn't there a 1 there? Right? Negative 1i. Oh, there is nothing to combine. Stays the same. Good. What's this? I can combine the j's. What do you get now? 2j. Good. Good. Easy peasy lemon squeezy. What do you think happens when you have 3 vectors? Right? Number 17, you got vector v right here plus vector w, oh, negative 5j. And then we need another color. Let's maybe take pink. It's available. So now you have 3 vectors to add. Because what does getting the resultant vector actually mean? Add your vectors. All right. So number 17 here. The resultant vector will be I plus 4j. Minus 5j. 8i minus j. So I want you guys to see this here. Here's my first vector plus my what? Second vector. And you might say, I don't see a plus. Okay, I will put 1 for you. What's that third vector? Combine like terms. 1i plus 8i. What does that give you? 9i. 4j minus 5j minus 1j. What does that give you for your j's? 4. Is that minus what? Minus 2j. So if they give you 3 vectors, what could you guys do? You add them, and again, this is why you care about the ij form. Double check. Did we make any mistake here? Is that right? You guys okay with that? Notice it goes back to beginning algebra. Is that true? V. And then what? W. And then what? U. Combine like terms. Let me try to do it right in here. Okay. See if we can squeeze it in. So vector R, ladies and gentlemen, will be negative what? 2i minus 6j plus 4i plus j plus 3i minus 2 what j? Okay, so you get negative 2i plus 4i plus 3i. So isn't that going to be negative 2i plus 4i is 2i plus another 3i. Doesn't that give you what? 5i. Good. Now do the what? The j's, combine like terms. This is a 1 there. So what do you end up with? You get negative 7 what, j? Is that true? Because you get negative 6j plus 1j is negative 5j. And then add another negative 2j, that's negative 7j. And sure enough, ladies and gentlemen, there you go. This is the reason you care about the ij form, because when you do vector arithmetic, or I should say, when you find the what? Resultant vector, ladies and gentlemen, the ij form is very, very what? Useful, okay? It's very useful. There it is. Easy peasy, lemon what? Squeezy. This is why you care about the ij form. What do you guys think? What's that? Yeah, so now you guys can be able to do the what? The homework. Is that true? Did I put that homework in the assignment section? That's right. Okay, we'll see you guys tomorrow. Take care, stay safe, have a wonderful day.